Well, the very last one it said relative maxes and mins, I think, on F prime will be what on F double prime? And I put inflection points. There'll be inflection points on F, but not on F double prime. On F double prime, there'll be x-intercepts. But I did fix that. If you haven't checked that, that is a mistake. And I don't know how that's not a new key. I mean, that key has been around for at least 2 or 3 years, and nobody's noticed it. So props if you caught that, that's great. But that was on page 150, but it's I erased the page numbers because the page numbers change every year, but on the new scan, it is correct. So if you look now, you'll see it correct. All right? So anybody got any question from anything on that classwork, homework, whatever, anything on there? If you're feeling good about it, that's great. That example 2 yesterday was a huge thing for you. I mean, if you can do that example 2, and if you don't know what I'm talking about when I say example 2 gave you an f function, right? And I put that little chart at the top again. It gave you an f function. I asked you all kinds of questions about f. Notice that f, all kinds of stuff, and then how does this stuff f show up on f prime? But we began with f. On the next curve, don't be confused by this. I'm not saying that f suddenly is f prime. I'm saying forget about f, the other problem. Look at this one. What if this same graph was not f, but it was f prime? And now I'm going to ask you still questions about f. Don't look at this and go, oh yeah, look, f is increasing. F is not increasing. What's increasing here? F prime. And what does that mean about f? Well, again, you can go back to your chart and say, well, if I know that f prime is increasing, what does that tell me about f? That would tell me f is concave up. And what does it tell me about f double prime? Oh, f double prime would have positive y values. But again, if you can look at these graphs, and you are like I would be willing to bet, if you do well on this test, you pass the AP test. Like literally, there is that much about the AP test that talks about giving you different versions of the function, whether it's f, f prime, f double prime, and asking you questions about the other functions. If you get this down and you're really comfortable with this, you are on your way. Easily passing. Because there's just so many easy questions that they try to make ugly, but ultimately you're like, that's it? And it really becomes this linking kind of thing and this kind of understanding. It shows up all the time. I mean, honestly, I have pulled some of those AP questions out and showed you already, and you've seen them. We'll look at some more today, but a lot of them are mixed in with topics you don't understand yet, but ultimately it boils down to this. So hopefully you're getting that and you feel pretty comfortable with it. Anybody, before we move on, have any questions on that? Okay, so let's jump to the AP practice problem stuff. And I just want to, if you have questions, guys, I want to answer them. But ultimately, I just want to go through some of this. And I don't know what page this is for you. 153. It's already 157 for me. They constantly change. Anyway, so right here, and this is a common way AP will ask stuff. They'll say, hey, if the derivative is this, then where does f have a relative min? Now, what are you normally doing when I ask you about relative mins? Normally, I give you the function, and I go, where are the relative mins? And you go, well, I got to find the derivative. I got to set the derivative equal to 0 or d and e, right? And you find all those critical numbers, and then you mark the critical numbers on your number line, right? And you start checking, and you try to see where the graph of f did what? Had negative slopes to positive slopes, or went decreasing to increasing on f, right? And that would be a relative min there. And it said at what x values. So I didn't ask you for the y, I asked you for the x's. But this time, what did I give you? I just gave you the derivative. Okay, so if I give you the derivative, then you don't have to worry about actually finding it. You just have to do what? Set it equal to 0 or d and e. So if I set that, the derivative, equal to 0, I'm essentially saying, all right, that is equal to 0. Can you solve this? Cube both sides. And you can factor that if you want, or you could just add 9 and square root both sides, right? So when you factor it or add 9 and square root both sides, what do you get for x? Plus or minus 3. So at plus or minus 3, I have a what? I have a critical number. Okay? Now, how would I bother to check and find out about maxes and mins? But on a number line, what would I be doing? And I don't have an original function, right? But I do have a what? I can check the derivative values in between there, because I do have the derivative. So I would check maybe, all right, let me check -4, maybe check 0, maybe check +4. And if it's easier to pick something different, pick something different. So if I check the derivative at -4, there's the derivative, I get what? 16 minus 9 is 7. Cube root of 7 is clearly what? A positive number. So that would tell me that the original function increases, but because it's positive, so right there I know that there's not going to be a relative min there. If anything, there's a max, right? But so let me check in between here and here. If I plug a 0 in there, I get a cube root of a negative. Now I can cube root a negative. That doesn't give me an I, that just gives me a negative because it's an odd root, right? Only square roots of negatives give me I's. So that gives me a negative, so it's decreasing. So if that increases, I know that I have a min there. If I plug a 4 in there, 16 minus 9 again is 7, so that is positive. So you can see right there at 3, I have a relative min, but not at plus or minus 3. You with me? All right, what about this next one? Now, a lot of times it'll be a calculator problem. Yours won't be, but on a calculator, again, just graph this. You don't have to do all this check. And if I graph it, you know what the graph ends up looking like? Yes? It looks kind of like this, right? You seeing that? But if you look at the derivative, you'll be looking for where it crosses. Like, let's just say it's going to cross like this. Like this would be the derivative graph, let's just say. Hold on. Derivative positive, negative, positive. Yeah. All right, so that's what it would look like if you graphed it. Are you tracking with me? Or something like that, right? Because look, the derivative had positive values to the left of -3. It had negative values in between -3 and 3 and positive values. But you would just graph this derivative and go, oh, what is it? Oh yeah, look, when the derivative is 0 and goes from plus to minus, actually it wouldn't do that. Oh yeah, relative max. Then that would be a relative max. And when the derivative is 0 and goes from minus to plus, that would be a relative min. So, but that's a calculator problem as well. Except they would make it where you couldn't actually do this, so you'd be forced to use your calculator and look at the picture. But you won't have that today, on your test Thursday. All right, now I might give you this picture and say, hey, based on this, where's your relative min? And hopefully you can go, oh, it's where the derivative changes from negative to positive. There. You with me? Now I could also do this to you. What if I had this? What if I had this? What is going to exist there at, say, +4? On the original function, what would you see there? Positive values, negative values of the derivative. That means the derivative is positive on one side of 4 and negative on the other. Positive on one side, negative on the other. What could be there?
A relative max.
It could be a relative max if the point existed, right? So how would I know if the point existed here, since I don't even have the function? You wouldn't know. That's exactly right. They would either tell you something like it's continuous, or sometimes they might say it's differentiable, but they couldn't say that because clearly the derivative doesn't exist. But if they said it was continuous, you'd go, oh, it does connect into a corner or a cusp. Right? In this case, a cusp. Because if it's a cusp, that means it's getting huge. The derivative's getting really steep on both sides. Right? One really steep positive, one really steep negative, so it must be going into a cusp. But anytime you see the derivative go from plus to minus, minus to plus, plus to minus, that's a relative max or relative min if it exists. But we have to do it differently when I can't see the picture of the derivative. Unless you're really good at sketching this, which I am not. Are y'all kind of tracking with me? Now this isn't gonna look exactly like a parabola, but you can kind of see it as parabolic in nature, right? It just had this cube root on it. So the cube root would have changed it a little bit, but you still get the general idea. Are y'all seeing this? So I did way more than I needed to there, but...
Pardon the interruption, teachers. This is Dr. Barnes. Good morning.
Oh, yeah.
We are scheduled to have a drill this morning, a code yellow drill. At this time, I would like everyone to go ahead and move into their code yellow procedures and protocols. And teachers, if you will take this opportunity to express to students the difference between a code red and a code yellow and what those two type of scenarios entail. But at this particular time, if everyone will go in and go ahead and start the code yellow procedure, we're going to walk around a little bit, make sure the classroom doors are secured and closed. Continue to teach teachers. Again, code yellow procedure. Thank you.
So, I'll boil it down to just a nutshell. Code yellow, business as usual, we lock the door, we keep going. Code red, we are a target. So in a code red, in my other room, we were in pretty good shape, right? We had a door you couldn't see, and the window was on the second floor, and granted, we might have to jump out the window onto that little air conditioning unit, which is no longer there. But pretty safe, I thought. Here, we're just, for a mean person, we could be in trouble. So what we would probably do is line up all over here or down along this wall so nobody could see in and see us. And pray. So, but this is not a code red, it's code red. So we'll just keep plugging away. Also, I hope you don't have to have a And if you are in a code yellow or code red, I can't let you in on the code red. You know that, right? Like, have you seen the videos where, come on, let me in, and it's like scary video, and they open the door and there's a shooter there and it shoots us all. I can't let you in. Like, you can't go, oh my gosh, but come on, that's Emma out there, that's Emma out there, save Emma, because somebody could really be using Emma to take us all out. So that may sound awful, but on a code red, don't open the door, because you never know. Hopefully that stuff will never happen, but we're a pretty safe community, but you never know. So anyway.
That one time in 8th grade. You guys remember?
Oh, I remember that. That was so fun.
We were like
What was
sprinting
this?
down the hallway.
There's like
What
someone
about
was.
that one time, here?
I don't know.
Oh, sophomore year,
I
sophomore
remember
year.
seeing
I had a class with that guy, and it was just me, him, and Ryan. And that wasn't.
Oh, I can't remember. I think it was like talking about like somebody walked Maggie to our classroom.
All right, since we are videoing this, let's jump back and let's take a look at the next one. So this one, I gave you f prime, but I didn't give you the actual equation for you to find out where the zeros were, right? I just gave you the picture of it, which is kind of like what we were just talking about. So there's f prime, right? The graph of f prime is at the right, but they're asking you about f. So where would f have a local max? I'm sorry, a local min or a relative min? Well, again, if this is the derivative, and the derivative is changing from plus to minus, is that a relative min?
No.
That's a relative max. If it's changing from negative to positive, the f prime is?
Yes.
Is that a relative min? Now it asks you about the x value. So the actual x value of the min would be at -1. And then right here, this changes from plus to plus. What would that look like on the function? Yeah, positive slope to zero slope to positive slope would be some horizontal tangent line, horizontal layout. So this has one relative min. But notice they're always going to give you something like, oh, you look at -2. Well, they didn't. They were stupid. They should have. They should have given you like -2, because there's always a sucker that goes, oh, look, relative min. Like it did give you +2. Kind of looks like a relative min. But don't get sucked in by that. Remember, they're giving you the f prime. You have to lock in on that. If you don't pay attention to that, you're going to miss tons of questions. If you do pay attention, this is going to be a pretty simple test, I think, if you know these basic things. Are you with me? Now, can you find the actual relative min here? Well, yeah, if you could somehow integrate this somehow and deduce what the function is, but you're never going to find that, because you remember what we said about integrating? When you integrate a function, what does it always produce? That's c value, and the c value controls how high or low it is, because it's the y-intercept. So we'll never know unless we knew the original function, or maybe some other points that would help us. But we will get there about integrating, and you will learn how sometimes you can find the original function if you're given enough information. But in this case, we'll never find the actual min, but we can tell where the x value is. All right, what about A? It says, now again using this, the local max would be where? At -3. Good. All right, now what if I said, all right, we're going to use the same graph as before, but this time we're calling it F double prime. It says then the graph of F has points of inflections when. So now I'm saying, what if this same graph is F double prime? Where would I have inflection points? Now a lot of people say the zeros, but those are possible inflection points. They're inflection points if what? They change signs on either side. And look, F double prime plus minus, that's an inflection point at -3. Minus plus, another inflection point. But plus plus, not an inflection point. Somehow that went concave up, concave up. Concave up, concave up could have just been a big concave up area, right? But it also could have been like concave up, concave up. Although it would look like that, concave up, if there was like a D and E there, all right? But anyway, in this case, it would just be one big concave up from there to there. And I think I can put a note about that somewhere on your homework or on something tonight. I put a little asterisk by something and said, hey, go back and look at this, about why you get, what that looks like when you have a double concave up section. But anyway, whatever. All right, so right here we'd say -3 and -1 if this was a F double prime. I don't know why I didn't just bother to copy that graph, but maybe I ran out of space. All right, what about this maximum value on that? It's really easy to forget what we learned about maxes when we learned something about relative maxes, but the maxes, do we have to check where the graph goes from increasing to decreasing? Those are relative maxes. But what could also happen? Maxes could occur where? At endpoints. So yeah, you can look, you can do a number line analysis on these things and go, oh, there's a relative max there. But there still might not be a max if it's going up forever, right? And if at 2, at the end, if 2 is down here, then you might go, oh, well, that was higher than that. But if 2 is over here, shows up over here, then this might be it. So I don't even bother to check a number line analysis. I don't do that to see where the relatives are. I just check all the critical numbers in the function along with the endpoints. And that's the extreme value theorem, right? So the extreme value theorem says maxes and mins occur at critical numbers and endpoints. So how do I find critical numbers?
Find the derivative.
So take the derivative and do what? Right, great. Now remember, to show me your work, write derivative, take the derivative, set it equal to 0 or set it the part equal to D and E, but there is no denominator to worry about here. Factor whatever you can out. Factor it. And guys, I had a number of you do this on a test, and I'm hoping it was careless, but you said, oh, the roots are 0, 2, and 1. Why is that wrong? Yeah, if I set 6 equal to 0, I get D and E. All right, if it was 6x, yes, 0. But don't do that. So those are my critical numbers. Are both of those in that interval?
Yes.
So I want to consider both those, and I want to consider the endpoints. And I plug those back into what? Okay, I also had a lot of people do this. -1 arrow, 2 arrow, 1 arrow. And you did this little mapping diagram for me, which I know what you're talking about, but the AP reader is only allowed to give you credit for statements that are true. 1 arrow 7 doesn't mean a lot to people, okay? So what do you want to write here? F of that equals F of that, because you're checking the value of F, right? F of that equals. And then just plug it in. You don't have to show all your work. A -1 in there gives me a -2. -1 in there stays -9. -1 in there becomes -12. Minus a 1 is what, a -24? A 2 in there becomes a 16. 2 in there becomes a -36. Plus a 24 minus a 1, which is what? 3 maybe? Correct me if I'm wrong. And then this 2 minus 9 plus 12 minus 1, 4 maybe? So the maximum is 4. It's the maximum value. The max is not 1, right? The max is not the 0.14. Now listen, AP, if they just say max, we only want what? You will continue. If you write this as the max, you will continue. I'm going to do this, and I'm going to continue to take points off. And at some point, you're going to miss the whole question, because 1 is an option. That's the x value where it occurred, right? They're going to suck you in and beat you down by this. Sometimes I have seen them show the x value, I've seen them show the point, and I've seen them show the y value. And you have to know what it is. So remember, now if it says the maximum value of blah will occur at x equals blank, then say x equals 1. Yeah.
If you write like f of 1 equals 4, would you know?
I don't like it.
Okay.
I don't. Because again, I know I like that you understand that. And you could say at x equals 1, the max is 4.
Code yellow is now complete. Again, code yellow is now complete.
I have seen people write, hey, at x equal 1, the max is blank. But yeah, you don't have to say, you don't have to be overly, I know a lot of you are doing that. It's like, I feel like I'm cheating if I don't write it enough or if I don't say enough. Just throw the y value out there. All right? All right, what about this? If that equals that, the critical numbers are? How do you find critical number?
Take the derivative.
Take the derivative. How do you take the derivative of this?
It's x plus 2.
Product rule? Okay, so the derivative is first d second minus second, plus second d first. How do I take a derivative of an absolute value?
U applies derivative of U over the absolute value of U.
So
Yes.
u means the inside part
Yeah.
times the derivative of the inside part times the absolute value of the inside part. I'm sorry, divided by the absolute value of the inside part. Derivative equals 0 or dne. So the derivative equals 0 or dne. Now how do you determine where it's dne? Where the denominator equals 0. Okay, so the denominator is going to equal 0. I can say, we'll do it over here. The denominator equals 0 when what? Pretty easy to see that, right? When x is negative 2. And then when is the whole thing equal to 0? When the numerator equals 0, right? How do I do that? You might want to get a common denominator so you know what the numerator is, right? You can't go, oh, well, this part and that's the numerator. It's not a common denominator yet. So how do I find a common denominator? So I would need an absolute value of x on the bottom, and then another one on the top, right? Now what happens when I square an absolute value? Is the necessity to have the absolute value needed anymore? Because absolute value makes it positive, but so does squaring it. So couldn't I just ignore that absolute value at that point? And say I have x plus 2 quantity squared plus x minus 4 times x plus 2, and that would be the numerator of all this?
Yeah.
So I could say that equals 0. So for the 0 part, that needs to be true. For the dne part, that needs to be true. And then I just have to solve it. So x squared plus 4x plus 4 plus x squared minus 2x minus 8, 2x squared plus 2x minus 4. I can divide a 2 away or factor it out. And that factors into x plus 2, x minus 1. And what are my critical numbers then? Negative 2 and 1. Do they both work in the original function? Yes. There's no place where the original function is undefined. So negative 2 and 1. Y'all with me? Okay. What about number 7? Let f of x equals that parabola. F of x has a minimum value on which of the following intervals? Whoa, now a lot of people look at y equals x squared. They go, what's a parabola? The minimum is that x equals 0. But this says, has a minimum on which of the following intervals? It's not testing your knowledge of a parabola as much as is your knowledge of the extreme value theorem. When are you guaranteed to have a min? What's the extreme value theorem? What is it guarantee? It guarantees you'll have a max or min if what? It's continuous on a closed interval.
Looks pretty continuous to me.
So it's definitely continuous, but is it continuous on a closed interval? Open interval? Open interval? Closed on one end, so there's no guarantee for the mean value theorem. Okay, because you didn't have a closed interval. So there's not a guarantee there is one. So what we need to do is think, okay, what would this graph look like? If this is the parabola, and I'm looking at -1 to 1, then I definitely have a min, don't I? So I definitely have a min on this interval. Now, if I'm looking at 2 to 3, from 2 to 3, am I going to have a min there? Because remember, it's an open interval. So if I have an open interval right there, I'm looking at just that, do I have a min? Mins cannot occur at open spots, can they? So even though I got down close to whatever that was, close to, that would be a height of 4, I'll plug a 2 in there, it doesn't exist there. No min there. What about from -5 to -2? Here's -5, there's -2. That would be closed though on the -2 and open on the 5. If it's closed on the -2, would there be a min there? Yes. Are you seeing this? So they're testing some basic knowledge of you, some understanding of, do you know that you can't have a min at an open circle? You can't there, but you can at a closed. But there's no guarantee on any of these because I didn't have closed intervals. Now, if it was a closed interval on both sides, you're guaranteed to have one. If I put the bracket on the -5 and open on the -2, and this is coming in, this is not, no min. There'd be a max, but no min. And notice I'm drawing a picture whenever I have a shot. If I'm confused at all, man, draw a picture. Take a look at it, kind of help you think through it. All right, this is kind of like your, this is more stuff from your review. And if we get through all this, awesome. If we don't, finish it up. Make sure you review everything and feel really confident with all this. And make sure you know how to write that chart out correctly, right? The F increasing. If you don't get that down and aren't using that, you can still find a way. I mean, my kids used to before I kind of started preaching that. But they had a much more difficult time with it. All right? All right, so right here, this is what function? Oh, F prime. It's so important you notice that. You don't notice that, you're like, oh, F. F is decreasing. No. Okay, this is F prime. So right here, give the coordinates of the relative mins. It would be on F. So if this is F prime, where do you have a relative min? At x equals 4. Because the derivative went from negative to positive through 0, right? So you went a negative slope, 0 slope, positive slope. Must have been a relative min at 4. And where are you going to have relative maxes? -1? Awesome. And what happens at x equal 2? Yeah, it'd be like a negative slope, 0, another negative slope. So we're just going, flattening, going. I'm not kidding. When we get to March and April and I start throwing practice tests at you, you're going to be like, dude, this question showed up like 5 times on the test. I'm like, I know. It's like 9 points or more. But like, I mean, when I say shows up, I mean like directly, like literally that question. They either give you an equation where you have to do the number line, or they give you the derivative, or what. Just so much more simple than you think once you really get this stuff down. Where would the second derivative of f be equal to 0? Relative maxes and mins on f prime, right? Because if this is f prime, the derivative of f prime is f double prime. So the derivative of is right there is 0, so the second derivative of f is 0. The derivative of f prime is 0, so the second derivative of f is 0. Derivative of f prime is 0, second derivative of f. So Where would that be true? Ballpark me.
Negative.
Negative 0.3 maybe, 2, maybe 3.5. And that's gonna happen on your test, so anything close. I mean, like right here, if it's anything between, I mean, it's definitely not -1. I mean, it's 0, so negative point anything is fine. And here, that's definitely 2, and then here, 3 point anything. I'm not quibbling about a decimal, so you don't either. Where are the inflection points of F? So where are inflection points of F?
The x-intercepts of F double prime?
Well,
Isn't that
but
just
we're
the
only
same
working,
thing?
that may be true. And not every x-intercept, but if it crosses, but we're only talking about F prime here, right?
Same points.
It ends up being the same points because there are no layouts there, are there? But think about it, what's happening to the slopes of F prime? Which are the second derivative? The slopes of F prime are what? So the second derivative, no, the slopes of F prime are negative. F prime is decreasing, but the slopes of F prime are negative. Is that true? This is F prime. The slope right there is a negative slope. What's slope of F prime mean? F double prime. So F double prime negative. F double prime negative. F double prime 0. F double prime positive, right? What happens when you go concave down on F to concave up on F? Right? Doesn't that mean that the F function is concave down? If the second derivative is negative, the F is concave down. If the second derivative is positive, the F is concave up. And if the second derivative is 0, it's a possible inflection point. But we're talking about F, right? We're using F prime to talk about F double prime to insinuate about F. And because of those links, I go, oh, the second derivative changed signs. At a 0, that's an inflection point. Or you could say, oh, that means F is concave down. That means F is concave up, right? So when you have a possible inflection point and you change inflection there, it must be an inflection point on F. Are you with me? And if I asked you, justify your answer, how do you know that? Well, you say what I just said. But you really probably want to talk more about F prime because that's what was given to you. Hey, don't say, if I go, what are the inflection points? Justify your answer. You don't want to go, oh, well, and by the way, it says where are they? So I'm not going to say, that looks like about what we'll call 0.3, negative 0.3. I want to say, yeah, at negative 0.3 there's an inflection point. But if I say justify your answer, don't say because the function changed concavity. Because the AP reader is going to look at you and go, F? I didn't give you F. Did I? But what could you say? I could say the slopes of F prime did what? Changed signs, right? Or I could say if F prime decreases and increases, then my concavity changes, right? But you want to really talk about F prime because that's what you were given. So, but yeah, it ends up being the same thing. But you know what? What if the graph had done this here? What if F prime had flattened out and then gone up? Now, you still have what? The slope of F prime was 0. Right here, the slope of F prime is positive. But what happens here? The slope of F prime is also positive. So the concavity never changed, right? So it's not that the derivative of the derivative was 0. Those are possible inflection points, right? On F. But it's that the derivative was 0, the derivative of the derivative was 0 there, and changed concavity. F changed concavity, which meant the derivative went from decreasing to increasing, or increasing to decreasing, or the second derivative went from negative to positive, or from positive to negative. Is this making sense? All right, what about this? Where would F be increasing? Why?
Because it's positive.
Can't say it. Can't say it.
Oh, because the F prime on the graph is positive.
That's all you have to say. So if I had said, justify your answer, if I had said to do that, you could just say, well, f prime's positive here. Right? Because when f is increasing, the derivative is positive, right? And the derivative is positive, so f must have been increasing. It's almost kind of hard to pull the trigger on that because it's f prime is so decreasing right there, right? But it's positive. If f prime is positive, then the f is increasing. But that's not the only place. Where else? 4 to infinity, it's also positive. F prime is also positive. Are y'all with me? Where would it be decreasing? From -1 to 2 and from 2 to 4. Now, a lot of people do this. They say from -1 to 2 and then from 2 to 4. But let's think about it. What's really happening? The values are doing what? They're going down, and then what happens right there? There's a layout, then it goes down some more on the f function. Isn't that what's happening here? If you have negative and 0, isn't the original f function just decreasing and then flattening out and then decreasing some more? But isn't that decreasing on the whole interval?
Yes.
So even though you could say, but wait a minute, you told me decreasing was when the derivative was negative. And 0, right there at 2, the derivative is 0. Are you with me? So the APCALC definition kind of suggests, wait a minute, it's not negative. 0 is not a negative number. I need to separate it into 2 intervals. But the pre-cal definition says, as long as your y values continue to drop, it's decreasing. And are my y values continuing to drop here? Yeah. So I really would rather say -1 to 4. That would be better. But I'll give you credit for either one on this. But APCALC will probably have it written -1 to 4. Y'all seeing that? That's why it's really important to understand what it's doing there, because if you understand what it's doing, you're like, oh, I can kind of trump that definition of decreasing means negative y values, even at a 0, because if it just hits 0 for one instant, the values are still going down. But I would give you credit for both, but this, in fact, sometimes I even look back at my old keys and I'm like, why am I still writing it like that? But I'll give you credit for both, but I think that's better. -1 to 4. What about this? Where would the second derivative be positive? When do you have a positive second derivative? Here. F prime is increasing. From our chart, right? Where is f prime increasing? From like, what, -0.3-ish or something like that to 2. And then from like 3.4, 3.5 to infinity? Justify your answer. If I asked you that, what would you say? Yeah, that is true when f prime is increasing. Like, so when I say justify your answer, don't be afraid. Don't go, oh my gosh. Literally write down what your thought was. And that's right. And do it as simple as you can. Tell f double prime is greater than 0 when f prime is increasing. And that's always worth an extra point. You justify your answer on these tests. Write down your answer, justify it. And don't write a paragraph, don't feel the need. Plus to minus, minus to plus. Use simple expressions whenever you can. Where would f be concave up? Same place, right? So when f prime, what would you say if I said justify your answer? F is concave up when what? When f prime is increasing. Now don't say f is concave up when the second derivative is positive. Because although that's a true statement, they're going to go, where's the second derivative? I didn't give you the second derivative. Are you with me? You always want to tie it back to what was given. So link it to, and you can put an equal sign there, f concave up equals f prime increasing. Really simple statements. Make sure they know what you're talking about, move on. And then that's concave down to just the other spots. Are you with me? Next thing. What if that's the second derivative? So second derivative graph. Where are their inflection points? Those are the possible inflection points.
What? Where it goes changes.
and changes signs. So I can say -2 certainly, because the second derivative had a 0 value there, and the second derivative had a positive value there and a negative value there, which meant the original function went concave up, concave down at that possible inflection point. That represents where an inflection point is. So you definitely have, it says where, I can't find the y value. Remember, inflection points are points, aren't they? So I would love to be able to say, hey, at -2, comma, plug the -2 back in the function and get the y value, but I won't be able to do that. So where, I would say at x equal -2. But normally I would say, what are they? But I can't figure that out from this. Now what about there? No. That had a negative second derivative and a negative second derivative. That's a concave down, concave down. It was just one big concave down region. What about there?
Yes.
That had a negative second derivative, a positive second derivative. That went concave down and then concave up, didn't it? That's an inflection point all day. So at x equals -2 and at 3, justify your answer. Oh no! What did you just do? You looked at what? Where the second derivative was 0 and changed signs. And changes signs. And don't say, oh, it changed from positive, negative, negative, positive. You can do that, but it's just more time. Changing signs is what was significant. So literally, isn't that what I just did to check that? Okay, so make it that, where's the second derivative? I mean, what x values on the intervals of the graph of f, whatever, would you have concave down? -2 to 3. Justify your answer. F double prime is negative there, right? I keep seeing people write F double prime has negative values, blah, blah, blah. Less than 0 means negative. It's just so much easier than writing out a paragraph. So F prime less than 0 here. Now if it doesn't say justify your answer, just write the interval. And then concave up, -3 to there, 3 to there. And don't put brackets on any of this stuff. Reserve brackets usually for domains and ranges, things like that, but not for intervals of whatever. Now, where would the derivative decrease? Right? Back to the chart, right? The derivative decreases when the second derivative is negative. So write that. Where is that decreasing? F prime decreases where F double prime is negative. Therefore, -2 to 3. Now again, actually, yeah, that's fine, -2 to 3. Actually, again, if you're ever unsure about, oh, but it's not negative there, it's 0. If you want to go -2 to 1, 1 to 3 on the concavity stuff, you can. Because there are times when it does go concave down, like that, but the derivative would not exist there. And here the second derivative would not exist. Here the second derivative did exist. It was equal to 0. And then increasing would be the other areas. Yeah?
Okay, doesn't ask to justify the answer, should we anyways?
I wouldn't.
Okay.
I would not. But if you got some free time on an AP test, I gotta be honest with you, I think AP is pretty weak about that. Sometimes I'm like, you just asked for this answer. You didn't ask me to show my work. If in doubt, show your work, I say, but if it says justify it, especially. There are a couple times on this test where I'll say justify your answer. So make sure that you're doing that. What are you feeling? Feeling all right?
Yeah.
All right, don't get cocky. You got a chance to get a really good score in the books. All right? Do the second grade this 9 weeks, right?
Yes, sir.
Do we get, do we have to stay in today?
Oh, yeah.
I know you can grow on this class, but
What did you ask for? The multitude thing, like math honors class. I don't know if it is.
Jonathan. Nolan. Iona.
Yeah.
Sweep. A nice sweep. I don't know if that's ever happened.
Really? So we have
Everybody in the class got one. It always stinks when I give them out to like all but one. And they're like, what's that? Nothing to see here. Oh, you made it really easy on me.
Last year in pre-cal, Mr. Lowe had to give out all of our National Honor Society invitations.
Yes.
He gave one to everyone except for me, and it was because he forgot mine.
I know, but isn't that
That
brutal?
was the worst feeling.
Yeah.
Well,
Not the worst, but
Yeah, that was
it's still a little, minor shaming. It's kind of like, dang it.
Don't they have like a
That was
national
the worst
convention for this in like Colorado?
that was my
They have like a
one.
national convention and like it's like a math tournament, but
It moves
lasts-
around. One year it was in Hawaii.
They have a lot of fun. No, my friends like to say go.
No, but Stiggins and Hoover, sometimes they go because there's a competition involved.
Oh yeah.
Yeah. That's how they claim their national championship. We've never gone because it's in the summer.
And it's like $1,000 per person.
Well, yeah, it's like the convention itself is like $550 or $650, and then you gotta get there.
They're
have
well,
extra
they have
meals,
conventions.
so-
We don't compete. It's a competition. There are different math tournaments, like different kinds. It's the whole thing. Mr. Harry, can I come by some period, but can I sneak in and do test questions as the class goes?
You can get here before class to do it.
Before class, yeah.
Yeah. Yep. Whoop.